Good day, matriculants, and welcome to another lesson in geography. Today's focus is on geographical skills and techniques. And as you can see, I'm switching from being a doctor to being your geography teacher. My name is Kamlan, and I will be focusing on GIS, the GIS concepts, as well as GIS applications. And for today's lesson, we'll be looking at specifically the GIS concepts. Now, if you remember clearly, we always examine GIS with a thematic approach. The concepts that we'll be dealing with today is data collection, data capturing, data processing, data analysis, data layering, data standardization, data integration, data visualization, data manipulation, and data management. So with these in mind, you've got to consider how is these aspects of GIS coming together. And for today, what I've done is I've included a thematic approach of COVID-19. Yes, this is a symbol for the COVID-19 virus. How would you describe this? To me, it looks closely like a soccer ball with a vuvuzela sticking out. Yes. However, what you should consider is this is a symbol of international standards by the World Health Organization. We refer to it as data standardization. But let's talk a little bit less about data standardization and save it for later on in the show. Now, let's focus on what is happening in our country today. Firstly, every day when you're on the television or in your media, you will find that information about COVID-19 is everywhere. Daily, the president will speak, as well as ministers, talking about the various different ways in which COVID-19 has affected our country. Let's bring in GIS. What kind of GIS parameters are used in order to influence what we see? The first concept is data. Now, what is data? You should know that when you use data, you are gathering information. But let's do a more scientific explanation of data. Data is information that is converted into a binary digital format. Now, this diagram looks something similar to a movie like The Matrix. However, what you should consider is all the aspects of data are confirmed in a binary. A binary is two numbers, 0 and 1. If you look closely into the definition, it is a base number system. Simply put, all the information that is gathered occurs as a binary, and as you can see, this information, it cannot be displayed. However, when you're looking at it from a perspective of the information that is shown on a TV screen, this is the information that is behind it. So, binary is a base number. And when we're looking at it, you will then find that GIS plays an important part in understanding what is this data. So, the basic type of data in a GIS reflects traditional data found on a map. When we're looking at these two basic types, what you should consider is that data is occurring in two ways. Spatially referenced data. An example of spatially referenced data is absolute and relative location, what we've become familiar with as vector and raster data. Now, these are normally represented as lines, points, and polygons, as well as the other form of data, attribute data. These are more descriptive data. So, what are we talking about here? All the data that comes in geography, especially on topographical maps, occurs as a binary in a computer system. When it's prepared as information, it shows you the binary in the form of vector as well as spatially referenced data. So, let's go deep into what is happening in our country. Again, remember that these characteristics are what's important. Now, let's go on to the first concept, data collection. In this particular slide, I want to refer to the COVID-19 epidemic that has beset South Africa. Now, if you consider this picture, what are you seeing? Yes, a temperature screening of the President Cyril Ramaphosa, as well as a medical worker who is screening him. Now, when you look at it, a device is important. What is happening in our country? One of the most important aspects of the COVID-19 is the tracking and monitoring of various different places and provinces in our country. And what are they doing? Everywhere in our country, there are medical workers as well as ground workers collecting information. Remember, this information exists as primary data or secondary data. When the President was tested, you will note that he was screened for his temperature, as well as he was, yes, biographical data. The age, how old the President is, the sex, is he male or female? Of course, our President is male. But all this information is collected as primary data, okay? And when it's collected, it is then put onto a device. Now, this device enables us to understand how GIS works. Once captured, the medical workers then send it to the central hub, which is in Pretoria, the CSIR, the Committee for Scientific and Industrial Research in South Africa, as well as the NCID, the National Institute for Communicable Diseases. How are they using GIS? Once a medical worker, wherever in the country, be it Free State, Port Elizabeth, Durban in KwaZulu-Natal, uploads information onto the device, they use what we call software applications, which is a chatbot. So, in terms of collection, you will note that the following must be remembered. The collection of primary data through surveying techniques. What is happening in this picture is a survey of an individual, a survey of the President, to collect information on his status with regards to COVID-19. You can also collect data in the form of secondary data. Remember, the secondary data is scanning techniques. So the key words to remember in this is when it comes to primary data, you use surveying techniques. When it comes to secondary data, you use scanning techniques. The collection of the information is dependent on the people on the ground. Are you thinking of GIS components? Good. Remember, you need people to collect information. This is the first part of any GIS. And remember also that when these people are working, they are collecting information, data collection. The next aspect of concepts that we're going to look at is data capturing. Now, I want you to differentiate two types of data when it comes to this concept. You have data capturing as well as data capture. What is the difference between the two? I want you to note the following. Data capturing is a technique, whereas data capture is a process. Let's define these. Data capturing is the technique that is used where data is digitized or organized in a GIS system. Let's go back to our technique. What is happening? You have medical workers on the ground. They are collecting information, data collection. Once collected, a device is used. This device is then responsible for capturing the information. What are the two ways you should be knowledgeable about? Data capturing or data capture. The technique is the capturing process. You need an individual, in our case, a medical worker, who will be capturing information onto the device. The process of capturing that information is called data capture. You must be able to differentiate between the two. So, can you see this process? The president has deployed various medical workers all around the country, and they are busy collecting information, data collection. The process that they are involved in is called data capture. And when they capture that information, the technique used of using software applications on a device like a tablet or a cellular phone is called data capturing. The next type of concept that we're going to look at is data processing. Now, the information that we've got is up to the 20th of March. Now, I want you to focus onto this diagram. So, we have in this diagram our medical officers who are capturing all that relevant information, all the information about the way in which people in this country, South Africans, are behaving during this lockdown. Are they increasing their temperature rates? Are they ensuring that social distancing is at a maximum? Good. So, once captured, this information is then transferred onto a device like a satellite. A satellite then transfers that information back to our COVID hub. Earlier, I spoke about the NCID, which is our National Institute for Communicable Diseases, as well as the CSIR. That is the hub of South Africa. All the information, all the data that is captured throughout the country then is processed and transferred into a central hub, which is based in Pretoria. Now, what is happening there? Very good. We look at the operation of using stored data, mostly on a computer, to retrieve, transform, as well as classify, to create information. Now, this brings up an important point. All the information is firstly known as data. Why? Because it has not been processed. You need the medical workers on the ground to capture the information, data capturing. Once it's transferred, it is becoming processed, data processing. And we require computers to process that information. So if you look at the next slide, it displays to you the process of data. Now, what is data processing? Data processing will be the uploading of information from the ground to a satellite and back to a central hub. Those central hubs are represented by computers. Computers then start processing that information. And as you can see, this diagram represents your binary codes. Can you see that we cannot see the words or the numbers? All this is basically housed in your binary code. And your binary code is moving between computers, transferring that very important information about the president's temperature scanning, about the rest of the country and its population, and their temperature scanning. So, when looking at this diagram, understand the following, that information is constantly in motion, in moving, is being processed. And how is it being processed? From the ground up, reaching the satellite well over South Africa, and then coming back to the central hub. What do we need as a next stage? You need a data analyst. A data analyst is a person who will then process that information to become more meaningful, which brings us to the next concept in GIS, data analysis. Now, you will note that data analysis cannot occur without an analyst. Let's look at the definition. Again, a process of cleaning or transforming or modeling data to discover useful information for decision making. Why is this important? Because we cannot represent information as a binary. We cannot just give the president, before he makes a decision, just certain bits and pieces of information. That information that comes through to the computer must be analyzed. And how do we analyze it? We start cleaning up information. What kind of information do we need? We need, where are the infection rates high? Where are people not practicing social distancing? Where is the lockdown not being observed? Our regulations from the National Command Center are processing these decisions based on GIS applications. Isn't that exciting? And when we look at it, it all comes down to decision-making for the country. The key words for data analysis, ladies and gentlemen, is the process, because every aspect of data is process. In this regard, we're looking at, and I want you to remember, the cleaning up of information, transforming of information, or modeling of information. Every day when you're watching television and you're watching and getting updates on COVID-19, you will note that during the news, a specific type of map is being used on a daily basis. That information is being processed by a data analyst. And this data analyst is responsible for showing you exactly where in the country the infection rates are becoming higher and higher. Let's look at the next one. Now, when we're looking at it in terms of what you've got to understand with regards to analysis of data, you will note that this is a model for the Eastern Cape. And in the Eastern Cape, we have been able to capture 10 up to 12 different individuals. And these individuals have displayed infection rates. Note the following. Let's use case number 3. The data on when, the data on male or female, the data on travel history, as well as the current isolation status. Now, all this information is being captured throughout the country, and the Eastern Cape is a model where you can see how our medical workers are capturing that information. And this is the interface that the president will be able to see before he makes a decision, or before any of the ministers make a decision with regard to whether the lockdown needs to move to the next level. So, the next one is important, and it's commonly examined if you've been looking and studying from your past year papers, data layering. Now, data layering is a very specific process in GIS. Data layering deals with your data that is points, lines, and polygons. And you'll be familiar with topographical map where the vector data, which is your points, lines, and polygons, are represented in topographical maps. Note the following. To create a topographical map, you need points, you need lines, and you need polygons. An example of points is your trig beacons. An example of a point could be your spot height. When it comes to line features, you're looking at roads, railway lines, as well as rivers. And your area or polygon features is your industrial areas as well as buildings. Now, note the following. Data layering is the organization or arrangement. I would prefer you to use either one of these two words when defining data layering in a GIS, into geographic data, into themes. Now, the key words have been circled: organization, arrangement, and themes. This is how a data layer is created to create a topographical map. Let's look at the applications of data layering. It's usually arranged as separate data layers. Now, the key aspect of data layering is separation. Each of those layers, whether it's a point, a line, or a polygon, occurs in a separate layer. And this separate layer can be extracted in order to give us useful information. So they may find that each layer may be useful or not, depending on how we're creating. Now, the creation aspect of your data layering is the topographical map, where it includes all the different thematic approaches. It could include a road, a railway line, or even a river. Those are your line features. In this example, we will look at the following. Data layering is in terms of organization and arrangement. However, what's important is the reference on a topographical map. Note that in your reference, which plays a key important aspect of explaining and understanding the information on your topographical map, the point features, for example, what we're familiar with, trig beacons, which we're going to call trigonometrical stations. Other point features, which include places of worship. Remember, H is your hospital, and these are also found on topographical maps. The next type of features are line features on topographical maps. Examples of these could be the national freeways, arterial roads, secondary roads, notice, track and hiking trail, railway lines, and these are represented by these line features. And lastly, your polygon features or area features, and these are used as the following. Remember, you can also be represented as cultivated lands, recreation grounds. Notice the difference. They cover a much larger area, whereas in your line features, they are represented in a linear format. When looking at data layering in terms of 2020 and the COVID-19, you will note the following. I'm watching television, and when I'm watching television, I'm seeing maps of COVID-19. How are these maps created? These maps are created, correct, with your vector and raster data. Now, what I have for you is the following. The first layer of a topographical map. In this case, we are using the map of South Africa. What is the first layer? Notice the first layer is vector data, which is a line, an outline of South Africa. Notice the outline of South Africa. This would constitute the first layer of a GIS, the map of South Africa, showing you the outline with regards to its coastline and international borders. One single layer showing you an outline of the coastal outline as well as the international borders of South Africa. Now, let's put another layer on top of that. Notice the next layer. You have now provincial borders. So I've placed my outline of South Africa on top of below, and what's on top? The provincial borders. Notice how the provincial borders are indicated. Here's the province of KwaZulu-Natal, which forms an outline against the outline of South Africa. So in terms of my vector data on this particular map, I have an outline of South Africa, I have an outline of international boundaries, as well as provincial boundaries. Notice how my GIS is created. Here, I want to know exactly where provinces are. For example, the Northwest Province. An outline of it is represented. Now, this constitutes my next data layer. Notice it has been arranged. The keyword, the arrangement. Now, let's apply this to COVID-19. So I'm the president. No, I'm not. Cyril Ramaphosa is. And of course, what does the president want to know? Where are the infection rates the highest in the country? Where are the people ensuring that we are testing the most? So the president asks for a layer of COVID infection rates. And in order to create that layer, you will note I've used raster data. Now, in this particular example, notice the layers. We have the outline of South Africa. We further have the outline of provincial boundaries. But we've included the third layer. And the third layer is the infection rates that are affecting us in this country with COVID-19. Note the following. These cases are up to the 20th of March, 2020. And immediately, for any decision making, you can see that the two provinces with the highest infection rates are the Gauteng province as well as the Western Cape province. Why would this be? Remember, this is closely followed by KZN. Why would this be? Correct. These are densely populated areas in concentrated points in South Africa. So the highest infection rates in the Western Cape are occurring in Cape Town. And when it comes to Cape Town, we've seen the outbreak much higher than most of the other areas in the Western Cape. When it comes to Gauteng, note you have Johannesburg and Pretoria. And we've seen that in terms of infection rates, when we've studied the Gauteng province, these two areas. Now, is there a correlation? Is there a decision that needs to be made with regard to infection rates in our densely populated areas? Immediately, I have a layer that tells me exactly, using raster data, where in South Africa the highest infection rates are. And if I want to add another layer, I can now see that these aspects are then tested in terms of my third layer, which has a numerical value. Now, with the numerical value, I'm able to see the infection rates in terms of numbers. Note, in this particular example, we're seeing that Gauteng has the highest infection rates, and always note that this information is up to the 20th of March, 2020, closely followed by the Western Cape. What you also consider in the data is 43 cases of infections cannot be detected or placed in any province in South Africa. Isn't this useful information? What do I know? What do I understand? Should I then be changing the levels of lockdown in certain provinces according to how the lockdown is being observed? GIS is very useful. And what's also important with specific reference to data layering is I can now understand and extract information as and when I feel. Can you see the television screen? When you're watching the news on TV, you would then understand that when you're seeing the map, that map has a lot of information behind it. This is how a GIS is created. And what am I doing with it? I'm making decisions. I'm looking at making judgments on South Africa in terms of how these infection rates are occurring on a daily basis. And note the values. So the next aspect of understanding is data standardization. Now, what you will notice that every day when you're watching your television, information that must be given to you is constantly given to you in the same way day after day. Standardization. What is important in any GIS is that information is represented in the same format so that the reader or the user is able to understand it. Let's look at data standardization in terms of how we use it on topographical maps. Firstly, the definition. Data standardization, again, is a process. Now note the keywords: into a common format that allows for collaborative research as well as sharing. So, in understanding this definition, what you should be considering is data standardization is a process that we need to ensure that common formats are used for collaboration. Collaboration simply means working together with the same information to make decisions. Now think about how in South Africa we are working together using the same type of formatted information on our TV screens. But now we understand that there's a lot that goes on behind it, and the GIS applications help us to be better collaborators as well as share that information internationally, because the World Health Organization needs to monitor all the countries throughout the world, and they need to set a standard of how that information is transferred from one computer to the next. So, in topographical maps, what you should consider is the following: that every aspect of line data, be it line data, point data, or area or polygon data, is standardized. Internationally, all maps are the same. And whether it's a road in South Africa or a road in the USA or the UK or wherever around in the world, all roads will be represented in the same way. This refers to data standardization. Standards that are set for representing point, line, or polygon area data. Now, when we're thinking of COVID-19, we've got back our soccer ball with a vuvuzela sticking out. But on a serious note, this is what we call a microdroplet. And it is an international symbol for COVID-19. And wherever you see this symbol, you know we're speaking to the specific virus throughout the world. What's important is you must remember that it is a common format to be used. So, the next aspect is data integration. Now, when it comes to data integration again is a process. You will note that all these concepts begin with the word process. So in my definition, I must use the word process. In this case, data integration is the process of combining data from different sources into a single unified view. What is happening here? All the data that is being collected after being processed and analyzed needs to be integrated, be it information about age, information about sex, whether male or female, or information about location needs to be unified into a single view. With regards to COVID-19, how is the single view represented? It is represented by, you guessed it, the curve. Everywhere around South Africa, we are talking about the curve that needs to be flattened. This is the best representation of integration. Note the following, and if you haven't understood the curve, now's your chance. The line that is represented on the y-axis, remember, this is your y-axis, this is your x-axis. The line that is represented on the curve on the y-axis is our medical capacity. That means how many beds and medical workers do we have in the country that can help with the increasing infection rates. The line that occurs shows you the infection rates. When we're talking about flattening of the curve, we are trying to get the line below our capacity. Why? We need to always ensure that, yes, we have more beds and medical facilities available than infection rates. If the infection rates goes above the line, as it is in the first graph, you will note that our medical facilities will not be able to cope. If the line is below, then you know that the line is flattening. What does this mean? Our infection rates are lower. See the data integration. Can you see? The data was collected, the status of various individuals in South Africa after being screened and tested. Now we are able to make a judgment through data integration. And this integration is the combining of data from different sources into a single unified view. The best application is the flattening of the curve. The graph that shows you the capacity of South Africa medically to ensure that the infection rates are lower. Let's move on to the next concept. This is another example of data integration. Now, note this is a world map, and in this world map, we are able to see the different layers. In this case, there's our key, and it shows us the infection rates. And immediately, remember, the infection started off in Wuhan, China. And look at how it's spread throughout the country. More than 30,000 infections. The concentration of this COVID-19 in Western Europe, the UK. If you were following the news, you will note that the most infections happened in Italy as well as Spain. Now we are able to represent that graphically in a diagrammatic format using GIS layers. Can you see the layer of the number of confirmed cases? And also what happens here is that you are able to view with various different layers where this virus is spreading and how is it. Note in South Africa, at this stage, on the 25th of March, we were still between 101 and 1,000. Of course, as more and more tests and more data is collected, we are increasing in number. Why? Because we're not observing the lockdown. which we should. These are regulations, to the point where the rest of the world is also implementing the lockdown status. So can you see how GIS has helped us ensure that we track and monitor not only South Africa, but upload information to get a world view, a global picture of this pandemic. Looking at the next one, data visualization. Now, when the president visits the National Command Center, he needs to see information. A GIS helps to better understand all that information is collected for decision making. Again, we have the flattening curve, and you'll note the following. Let's start off with a definition. Our visualization, again, is a process. And in this process, you have the process of visually communicating information to ensure that the data is represented. How? Why? Because every day decisions need to be made. And this information must be communicated not only to the president and the ministers, but everybody in the country. Daily, when you're listening to the radio or watching the television, you are seeing an update, and it must be represented in a certain way. This is what we refer to as data visualization. So that when the president is in the command center, notice how the various different dignitaries are viewing that information of South Africa. If you look, there's a map of South Africa, as well as your data analysts. They're sitting there and explaining to the president where the most infection rates are occurring. Here's President Cyril Ramaphosa. And what is he doing? He's thinking about, are my people of South Africa listening to me? Are they observing the lockdown as I've requested? Are the regulations being adhered to? Is there social distancing? Can you see the GIS behind this? What is it doing? It is informing us in a specific way, visually, how and where these infection rates are occurring, and how important it is to represent that information visually. Data visualization. So, what happens next? Now that the president has seen and understood the infection rates, he wants to know specifics about this information. A GIS would then assist him to make those decisions. What's his first question? My first question as a president to determine whether I should remove the lockdown is, where in South Africa is the most infection rates? And data, before we go further, data manipulation, remember, again, is a process of changing data. Notice my keyword, changing data into easier readable or more organized. And as our president is asking, where in South Africa is the COVID-19 epidemic the worst? And his information is represented on a map. Note how many layers are occurring in this particular manipulation to show and understand where these viruses are occurring. And this map represents, yet again, now if you look at this particular map, you will see that according to this particular date, on the 26th of the 4th, 2020, the Western Cape had overtaken Gauteng as one of the highest infected provinces. Gauteng still remains high. What is the president thinking? What are the ministers thinking? All the health workers? What's happening in the country? What kind of information do we need to better understand how this infection rate is working? So the president says, give me a representation of the infection rates or death rates in terms of COVID-19 in South Africa. And then the next layer comes through. Coronavirus deaths by age. And what you will note is the following. The layers of male and female come together in a graphical format. Immediately, we can look at this particular graph and make decisions on age-sex ratios, population dynamics. And when you're looking at it, you will find that most of the concentration of infections are located in the greater than 75 category. Which means simply, and if we look at the world statistics as well as South African statistics, our aged population is more vulnerable to the COVID-19 disease. So that means that the president has to make certain regulations together with his ministers to ensure that the population above 75 years old is protected. This tells us clearly, and how did we get it? Through Geographic Information Systems, GIS, which has assisted us to map out the country to ensure that we have relevant statistics coming through, which is captured, processed, analyzed, and now representing a visualization that is able to give us better decision-making skills. Now, how is GIS used as a management tool for decision-making? So if you are the president, what do you say? You say that if these are the circumstances, in certain provinces, there is a high rate of infection. In certain age groups, males are more vulnerable than females. Certain age ratios are much more vulnerable. How does that influence my decision-making? How do I then manage the country in order to ensure that the curve is flattened? Can you see all the GIS applications? Without geographers, where would this country be? Good thinking, isn't it? So, ladies and gentlemen, the next aspect is, now that I've seen that, I implement regulations in the country. Have you been to a grocery shop recently? Have you stood in queues? What have you noticed? On the floor, the shop managers have put in demarcated areas. Your trolley and you are only allowed a certain distance in front of and behind you to the next person. This is called social distancing for the rest of the country. But for geographers, we can refer to this as buffering. Now, let's look at buffering in terms of your topographical maps. In terms of topographical maps, the definition, buffering is a demarcation, keyword, of a map feature. Example, a point, line, and polygon. And this is important, measured in units of distance or time. Now let's look at our topographical map. Any topographical map that is used can be buffered. And when we buffer topographical maps, what are we doing? We are demarcating an area. We are delineating an area. But I prefer you to use the word a demarcation. And how do we do these demarcations? Looking at the map, I have my line feature, which is the N2. This is an extract from the map of Harry Smith. And how do I buffer? Notice I'm drawing a line which is a certain distance away from the N2 on either side. The distance between the line feature and either side of that road or national road, the N2, is what we call a buffer. The buffer makes sure that in terms of delineation, we have a distance between a specific point. You can do buffering in line features, in point features, as well as area or polygon features. So let's get back to our application of buffering. In buffering, when it comes to COVID-19, I want you to remember the following. You've seen it, and when you stand in queues, you know that you should be standing a certain distance ahead and a certain distance behind the individuals in front and behind you. This should be up to 2 meters with a minimum of 1 meter. Notice in this particular diagram, there is a distance between the two individuals there, and here's someone who's coughing. In order to protect yourself, you would then stand a distance. This distance that exists between the two individuals is what we call a buffer. In terms of GIS, the concept that you can use is proximity analysis. How approximate are you in terms of the person in front of you and behind you? Note a further definition. A buffer is an area defined by the bounding region determined by a set of points, specifically maximum distance from all nodes along segments of the object. And simply put, to explain to you in meaningful words, I want you to remember standing in a queue in your grocery stores. What are you seeing? Demarcated areas, proximity analysis. All you have to understand is these buffers are created in order to ensure that you are equal distance in front of and behind. Notice the distance. The distance is key in any buffer. Now, we can now define geographical information systems using all the concepts that we've discussed, using all the concepts that have come together in terms of data collection, data processing, data storage, data analysis, data manipulation. What did we have? We had various different aspects, concepts that came together in order for us to understand what is a GIS. And looking at the definition, remember, a geographic information system is the gathering, managing, and analyzing of data. Another definition that could be used is a computer program for storing, retrieving, analyzing, as well as displaying. A third definition that could be used is, remember, it helps organizations better understand spatial patterns as well as relationships. Can you see how important GIS is in order to understand the COVID-19 epidemic? Now we understand better how all these processes are coming together for us to manage, manipulate the virus in order to ensure that the curve is flattening. The last aspect that we're going to deal with is called the components of a GIS. Do you remember the components? Yes, there are 5 components to any GIS. Remember the following. Any GIS to integrate needs these 5 components. The first one is hardware. The second one, software. Third, data. Fourth, people. Fifth, methods and procedures. Now, let's apply this knowledge. This knowledge then brings these components together. What is the hardware? Correct, the devices that we use, be it a tablet, a cell phone, a computer. All these are your hardware, and they represent different ways in which the information or data is being collected. The software. Remember, the software is the applications. In terms of COVID-19 and our data management centers, we are using the software called Chatbot. Chatbot enables your medical practitioners on the ground to enter all the data on various different individuals. The next one, data. Remember that data is occurring in a binary fix. And what is happening is it occurs in a binary, but is represented graphically when it's displayed on a computer. People, of course, people play an important part. Your medical workers, your health practitioners on the ground, the president, the ministers, you at home, all people making decisions on what to do day after day during the lockdown based on the information that is being relayed to you. And of course, methods and procedures. All these methods that are used in terms of transferring data, in terms of decision making, is what constitutes a GIS and integrates all this information together. Now we know and understand better how these components come together, who or what is represented by these components. So, what is it? Now, I want you to think about this. In terms of examining COVID-19 with a GIS, what is a possible question? A possible question could be, suggest 3 ways in which a GIS can be used to assist the Department of Health in reducing the impact of COVID-19 in South Africa. You should be able to get this. Why? Because you can use all the concepts that I've given you in explaining and showing the 3 methods and ways, any 3. And we look at the following: the collection of data. And what are we doing? We're collecting biographical data of South African citizens. Wouldn't this help the health department better understand how this virus is occurring? who this virus is infecting, why the virus is infecting certain individuals. Another possible, mapping regions. Can you see the GIS assisting various different sectors of our economy, making decisions on where to open, which shops need to be opened? Exactly. And the next one is providing feedback for decision making. In this response, note I've used the following: data collection, and in this example, data layering, and in this example, manipulation. Remember, when it comes to decision making, we always refer to manipulation of data. So, what about COVID-19? Here's some facts for you to remember. All of us are talking about COVID-19, but what is it? It is actually the CO, which stands for corona, the VI, which is virus, the D, disease, and the 19, obviously, because it was discovered in 2019. So COVID-19 is an abbreviation for the coronavirus of 2019. Also consider the following, and I'd like you to remember, people are using the words pandemic and epidemic. The outbreak of this disease was in Wuhan, China. Patient 0, which occurred in KwaZulu-Natal, then brought in this virus, and then it became an epidemic. So when it's referring to a specific country, it is an epidemic. However, when it reaches global proportions, it becomes a pandemic. So first, remember, it's an outbreak. An outbreak is in a localized area. Then it becomes an epidemic, located in a specific country. And when it reaches a global scale, it's a pandemic. So, just a reminder, when you're looking at what we need to understand in terms of GIS, you should consider the following: conceptual analysis. You need to know all the concepts of GIS. What I've been able to do is identify the key words that you must remember in order to remember the concepts. What we've done today is GIS applications with concepts. That simply means used a thematic approach of COVID-19 to apply to geographic information systems. Isn't this brilliant? Now you can take various different scenarios and apply them to how GIS creates an enabling effect in order for us to make better decisions. Note the following. When we're talking about social distancing, you should be ensuring that you are creating a buffer between you, the person behind you, the person in front of you, as well as all around you. The next step, remember, sanitizing. You have to sanitize. Why? Because in order for the decisions to be made, whenever you touch something, you should be making the decision to sanitize. Manipulate your mind. The next one, where possible, use gloves. What am I doing? I am ensuring that through my decisions, I am carrying forward the regulations of, and of course, the last one there is, correct, face masks. Use face masks. So with that, be safe at all times. So thank you for today's lesson. I hope you are able to understand better how GIS applications have influenced and made sure that we are now in a better position for South Africa. With that, thank you for this lesson, and I hope you will study and remember your keywords in understanding GIS applications. Goodbye.